All right. So I'm back. I was away for a few days. Um, some exciting things were happening. We had a little baby, and and things are finally setting down. I'm mostly awake. I guess most of the time these days, and I'm ready to get back into the swing of things a little bit. Today, I wanted to look at the source code for GNU Guix, which is a couple of things. I think one is it's a package manager, or at least there's a package manager called Guix, and there is another, and there's also a an operating system distribution. Essentially, I think a distribution of Linux. Um, uh, that is that's based, where Guix is the package manager, the default package manager for that distribution. More people, I'm going to assume, are familiar with Nix than with Guix. Guix is Wikipedia is telling me that Guix is based on Nix, which I don't think that that's true. I'm not sure that there's any Nix source code in Guix, but we'll take a look and see. My understanding is that Nix has its own different programming language, which I think is okay. So it says written in C++, but I think Nix also has a configuration language that's called Nix. And the idea of both of them, both of these package managers, according to this summary I'm looking at, is that they're basically going to do content addressing. You identify a package with some hash, and that hash is going to include somehow a hash of all of its dependencies. And this is supposed to make it easy to resolve dependencies and have reproducible builds. So that's the claim. You might notice that there's some overlap between the idea of package management and the idea of something like Bazel, where Bazel's not doing package management, it's doing compilation. It's figuring out your dependencies from a compiler perspective, and Guix is more figuring out your dependencies from the perspective of you have a bunch of binaries, and these binaries depend on each other. So those dependencies will have to be worked out. I'm going to expect to see some sort of DAG or directed acyclic graph, and the package manager's job is to reason about that graph essentially. And what's supposed to make Guix and Nix different is trying to configure package management using something like a functional programming language, which will, I imagine, be a double-edged sword. So it's going to have functions, and functions are relatively powerful. And there's a trade-off with these sorts of systems where if you make them too powerful, it's too easy to get, to shoot yourself in the foot. So typically what you want is you want to have a system that's constrained enough that you can reason about it productively. So if the system doesn't have enough structure, then it's difficult to reason about. And one way of getting more structure is to be stricter about how expressive the package manager can be. So that's just, going in. That's kind of where my head is at. So I'm actually not going to really look at Wikipedia. I've got open some of Guix's documentation. They've got, I think this is a wiki, if I remember correctly. They've got a cookbook that tells you about things like packaging, configuration, running containers, and installing Guix on a cluster, which I'm intrigued by. But perhaps we'll look at that later. We've got a Guix reference card or cheat sheet, and then we've got the manual, which is I looked briefly at before. It's rather long and pretty comprehensive. It looks like this is the table of contents. And I've also got the here's the home page. I've also got the code open in GitHub. This is a mirror of the code. The actual code is hosted on Savannah. And then for the first time in these videos, I've got the code downloaded on my machine locally so that I can do things like have better search for when GitHub lets me down. Okay, so that's kind of the overview. Guix is mostly, my understanding, is written in Scheme or a dialect of Scheme called Guile. I think Guile Scheme. And I believe this scheme is a Lisp, right? So let me just verify that before I totally embarrass myself. Okay, so it's a dialect of Lisp. I don't know what makes it minimalist, but it claims to be a minimalist dialect. I wonder if where's Guile? So okay, we get like a family tree. Look at this. Okay, so Lisp 2 was abandoned. Poor guy. Okay, so Lisp we started in 1955, which I think we were still trying to figure out what a function was in 1958. So when did we get the lambda calculus? That was what, the 30s or earlier? 1930s. Okay. So in the 1950s, we barely have computers. Lambda calculus has been kicking around for 20 years or so, I guess. So and that's when we get Lisp. And then Guile starts in 1990. And I'm not sure if there's anything especially interesting about Guile that we should pick up from this page, but let's see. Is the preferred extension language system for the GNU project. Okay, so I have seen it show up in like configuration files, I think. And yeah, okay. Hygienic macro system. I don't know what makes it hygienic, but maybe we'll take a look at it. When using continuations with call CC, Guile copies the execution stack into the heap and back. Huh. Okay. All right, so Guile is, I'm just going to think of it as Lisp. I've never programmed in Lisp. I've never really even tried to read closely any Lisp source code. I've configured Emacs, so I've used Emacs Lisp, and I've probably worked through a few problems in a Lisp programming book at some point in my life, but nothing that I really recall. Okay, so let's look at the source code. In the main directory, we have M4, which might be the M4 microkernel. I don't know. We do have Nix, so let's see what's up with Nix. Po, I don't know what that is. Scripts, I'm guessing here are scripts. And tests, I think we'll look at. We have a file called to-do, which I guess we might as well look at. Did I open this successfully? Okay, purely functional program package manager. All right, and associated free software distribution. Cool. So, but am I on Linux? That's what I want to know. Okay. Can be used on top of an already installed. Okay, so I forgot to mention I'm also using Guix. I'm not as my host machine, but I am on a Guix VM. So I did a video with no talking where I kind of played around with Guix enough to do a sanity check on whether it could do some of the basic things I would need it to do. So I'm on Guix. I could do like Guix search, I don't know, XIs, and it should see if there's, I can install XIs. Which I guess maybe let's do that. And it's a package manager. Maybe one thing to draw attention to is this is installing stuff, I believe in my home directory. So this is installing stuff in user space. Do I have NCDU? Can I install NCDU? Consider running Guix pool. Okay. Followed by Guix package U to get up-to-date packages and security updates. I'll consider it. But first, I'm going to see if I can find out where things are stored. So I have this Git directory that's taking up most of the hard drive here, and that's just what'd you call it? That's just the source code for Guix. So there's nothing especially interesting there. So I don't actually know where this stuff is going. Do I have read permission on the? Yeah. So I guess it's going into Guix store. Do I have? So what's going on with Guix? Let's see. Oh, sorry, GNU. I don't know. So I mean, we'll see. We'll see what's going on with the layout, I guess, when we're looking at the code. But I am on Guix, so things are a little bit different than I'm used to. So, for example, Firefox is not Firefox; it's kind of the unbranded version of the Firefox code base, just like Chromium is kind of like the unbranded version of Google Chrome. And so things will, I expect, work a little bit differently. I think there's like a GNU JavaScript implementation that the browser is running that may not always render the way that default Firefox renders. So we may see some funny business there. All right, so back to the code. We opened a bunch of directories back here, but we never opened GNU. We never opened Guix, which I'm going to go ahead and assume are where the real party is at. So let's move these to the end, I guess, and just take a quick look at things like Nix. So it does look like there's some integration with Nix. So what's going on here? We have Nix daemon, libutil, libstore, and boost. Boost doesn't seem to be doing much. You've got asserts and exceptions. Is this the Boost C++ framework? Let's take a look at Boost general library format. Yeah, I think so. Boost.org. That sounds like Boost C++ framework. Yeah. Okay. So this is C++ libraries that somehow Nix is involved in. Libstore. We've got SQLite, the store API. So namespace Nix. Okay, so there's some Nixy stuff going on here. But it doesn't look like a lot. It looks like they could probably shed this dependency if they needed to. Okay, and then we've got path locks, optimize store. Okay, cool. What do we just look at? libutil, I'm going to guess, is utilities. And then what is Nix daemon? Is that, okay, not a lot. Nix daemon, so Guix daemon is going to define a bunch of stuff. Okay, so there's a fair amount going on in Guix daemon. And then what about Nix daemon? Is this more or less the same? Okay. This looks like there's some real stuff in Nix daemon. I don't want to dwell on this. I may at some point go back and take a look at the Nix source code. All right, so geeks.m4. What is M4? We've got some stuff about host CPUs. It's checking with Guix assert supported system. What is DNL? So I don't even know what it is. So M4 file format. I think maybe M4 file extension. You can convert them to MP3s. I think that's a different M4 computer language. Oh, GNU M4 is a general purpose macro processor. Okay. So became popular when programmers commonly used assembly language. In the first days of programming, programmers noted that much of their programs consisted of repeated text, and they invented simple means for reusing this text. So this is just, I guess, trying to get closer to, like, don't repeat yourself. It's like trying to get closer to like the Kolmogorov limit, I guess, in terms of complexity by compressing text somehow in a readable format is what I'm going to assume that is. I thought that there was a microkernel, but that's probably L4, right? Is there an M4? So yeah, the L4 is a microkernel family. Is there an M4 microkernel? No, there's cell 4, which is the like security focused one. Okay, yeah. So that was just me misremembering about what M4 might be. Okay, so tests. I mainly want to. My main question is: are there tests, and are there a lot of them? And yes, there do seem to be a lot of tests, which is nice to see. I guess I'm going to pick on a random victim here and see if it see what's actually, how large are the tests, and largeness I'm basically taking to be a proxy for thoroughness. So medium size. This could be a lot of small, tiny tests. It looks like some small, tiny tests. But still, that's, in my opinion, good, because now you can add to these tests. And here's a larger test. This looks like, what are we testing? Records. I guess they've decided there are a lot of corner cases to records, whatever records are. All right, cool. And then we already looked at M4. So what is to do? What's left to do? Okay. Maybe add a substitutor that uses the GNU-net DHT or libswift. Yeah, what are we doing with GNU-net? I think I saw something about GNU-net. And I'm not sure. I'm not really sure what it is. I mean, I know it. GNU-net, I think, is like an overlay network or a file sharing program, kind of like a peer-to-peer thingy. Maybe I think like BitTorrent, but at a lower level of the stack, I guess. Let's look this up. So DHT should be a distributed hash table. So I'm not sure what we're doing with GNU-net, and I'm curious to find out. We've got some user interface stuff, end curses support, I guess. Recommends field, for instance, some basic compile stuff like glibc, binutils, etc. would recommend each other. Geeks package I could ask interactively or allow users to follow all or none of the recommendations. Synchronize non-GNU descriptions with the FSD. What's the FSD? I guess the directory.fsf.org. Okay. Fix impossibility to restart on error after cal store has been started. You don't want to mess with your cal store. I'm going to assume that's a copy on write store. Let's take a quick look at what's up with GNU-net, just to make sure that, just as a sanity check. Okay, yeah, decentralized peer-to-peer networking. The framework offers link encryption, peer discovery. What is link in this? Is this that encrypts and decrypts all network traffic at each network routing point until arrival at its final destination? Okay. Peer discovery, resource allocation, and communication over transports like TCP, UDP, HTTP, etc., WLAN, and Bluetooth. It's got a mesh network, includes a distributed hash table, which is a randomized variant of Kademlia. Okay. What is it? I mean, maybe it's using GNU-net to distribute packages. I guess that would be a good guess. Okay, so what is PO? Doc, geeks, and packages under the PO directory. So let's clean up PO as we go. Okay, so these are .po files. And I don't know what a .po is. I'm going to guess maybe these are languages. Is there en.po? No, but there's de.po. German translation of geeks. Okay. So these are strings, and the identifier for the string is its English version. And then the message str is the German version when you load the German de.po file. Okay, so what is a PO file extension? Let's guess that it's a GNU-related PO files. The GNU getText toolset helps programmers and translators at producing, updating, and using translation files, mainly those PO files which are textual, editable files. This chapter explains the format of PO files. Okay, I don't know what PO stands for, but I guess internationalization is what you would call it. Okay, so we have one script in scripts, and it's geeks.in. And what is in? Maybe initialization. This looks like Lisp. We're going to define some stuff and let bind some stuff. Okay, cool. All right, so now we are in geeks/GNU, and then what's in geeks/geeks, and how do they differ? Do we get readmes? No readmes unless there's a readme format that GitHub isn't showing by default. Okay, so maybe there's a readme here. No, okay. So in GNU, we have bootloader, build, home, installer, machine, packages, services, system, tests, and artwork, bootloader, home, installer. So this seems like /GNU is maybe the what they would call GNU/Linux stuff. The operating system level stuff that has things like bootloaders, and I wonder if home is the home directory. I don't know. The home service. This module is similar to GNU system services module, but provides home services, which are supposed to be used for building home environment. All right. Okay, so we'll look at that, but it seems like in terms of understanding geeks, like the package manager, and all of that jazz, the real action is going to be in geeks/geeks. In fact, I'm just going to totally focus on this for right now. We've got a monad REPL and monads. Platform, I'm guessing, is going to detect platforms. PKI is, I assume, public key infrastructure. Profiling might be like performance profiling. Quirks might be special cases for different systems. RPM, I wonder what RPM is. Is this related to the Red Hat manager? Reconstruct. Okay, to construct RPM archives. It intended to be intended to be importable on the build side. Okay, so they're going to, for some reason, create RPM archives. We've got subversion download. We've got more tests. Although I wonder why they aren't in the other test directory. We've got utilities, workers, upstream. Yeah, let's look at all this stuff, I guess. Sets, SSH. SSH gets its own file. Serialization, self. Search paths, profiles. Let's look at a bunch of this stuff. I don't know what nar is. Have I opened that yet? Lint is good. IPFS, I wonder if that's for distributing packages over IPFS, which is like another distributed file thingy. I think interplanetary file system. Inferior.scm. Okay, graph. I wonder if graph is the main directed acyclic graph. And then they've got graph.js, glob, and git. G expression. Let's look at ELF. I assume is related to ELF binaries, discovery, diagnostics. So we're not going to look at all of this closely, but I do want to just get a sense of where the interesting parts are, where the complexity is, and if I'm going to try to use geeks, where should I look if something goes wrong? Channels seems like it's pretty fundamental, and build system. Android repo download. Okay. And then we've got directories. We've got tests, store, scripts, platforms, import, build, and build system. Build, I'm going to go ahead and assume is mainly like hooks for calling different languages. Yeah, so we've got Ruby. We've got Maven, which I'm going to assume is the Java Maven repository stuff. Julia, Guile, Go. GNU. Is there a GNU language, or is this just, I don't know, Emacs? Elm, Dune. Okay, Cargo is Rust. Do we have Haskell? So we have Qt, Python, Perl, R. I don't know what Rakadu is. Is it a package manager for a language? For Raku. Okay, so I think that's like the Perl successor. And then what is so OCaml. So do we have Haskell? Haskell. Okay, cool. All right, fun time. So that's the build system. I'm not going to look at stuff in there really. And then build has some stuff. Emacs build system. Dune, I think, is maybe OCaml. Haskell build system and some other stuff. Okay. Import. What is in platforms? So PowerPC, ARM, MIPS. Okay, so these are the different CPU types. Scripts is, authenticate. Challenge. Deploy, I'm interested in. Describe, discover, download. Environment. GC is maybe garbage collect. Graph, hash. There's no way I'm getting to all of this. Upgrade, time machine. I wonder if this is different from the Apple time machine. Store. Okay. We've got a database, deduplication, roots, schema, and SSH. I guess we've got so much going on, I'm going to ignore most of that. All right. I think IceCat opened these in basically a random order. So can I make it so open tabs? I think there's some setting that will improve this situation. I don't know. Is it called similar? Maybe this is a blah, blah, blah. Okay. All right. I'll figure that out later. Okay. So yeah, but now as a result, I have no idea where anything is. Okay. So I guess let's just go through them in order. Okay. So here's authenticate. This is going to have security implications, I'm sure. So we're going to, I guess, again, I don't really read Lisp. I certainly don't read, what's it called? Guile. But I'm going to guess that this is defining the module. It's kind of like Haskell, that this is defining the module scripts /authenticate, scripts authenticate. Those are the two arguments. And then use module means it's going to depend on these other modules. So we've got byte vectors, binary ports, rdelim, match, vlist, iconv, and it's going to export the module geeks-authenticate. Gcrypt p crypto seems like it must be doing a lot of the work, and then PKI, I guess, does a bunch of the work. So this program is used internally by the daemon to sign exported archive, maybe, and to authenticate imported archives. Okay, so this is, I guess, mainly used for signing and verifying signatures. So read canonical sexp. So we're going to read a gcrypt sexp from a port and return it. I don't know what a port is. Is it like a port, like a network port? All right, and we've got some key loading stuff. I wonder, what is it going to tell us what algorithm it's using? Sign with key. Sign the hash, the SHA-256, a byte vector with secret dash key, a canonical sexp, and return the signature as a canonical sexp that includes the SHA-256 hash, the public key, and the actual signature. All right. And then we're going to validate. Yeah. Okay. So I see. All right. Read command port. Read a command from port and return the command and argument as a list of strings. I don't know what that means. So is this like the command pattern? So commands are new line terminated. It must look something like this. Command 3:ABC, 5:ABCDE, and 1:X, where command is an alphanumeric sequence, and the remainder is the command arguments. Each argument is written as its length in characters, followed by a colon, followed by the given number of characters. Are we doing arbitrary code execution? Like, I don't know. Like, I'm wondering how this handles somebody deliberately trying to break it. It seems like it's gonna take a command, and I assume do something like evaluate it. Let's see if it calls like some version of evaluate. So we're gonna consume white space. Match is maybe match read delimited blah 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 port. Maybe that's like a regex match. Something. And we're gonna have a command. And consume whitespace port. Look ahead. We're gonna check for new lines. I guess reverse the result. I don't know why. Is that reversing this stuff? I don't know. Read delimited port. Loop con string result. Now, but what did this do? Read a command. So this is just reading the command and return the command and its arguments as a list of strings. So this is just, I guess, parsing strings. This isn't evaluating anything yet. Define syntax, define enumerator type. Entry. Here's the entry point. So Guix authenticate is going to take some args. I'm not sure what the dot means. Category internal, that maybe is like some sort of metadata about the kind of function it is. And here's a descriptor. We can send reply. We can call with reply of a thunk. Send a reply for the result of thunk or for any exception raised during its execution. Send reply is going to send code and string as a reply to our client. Okay, I don't really have a sense. I don't really have a sense of what's going on because I don't know enough about Lisp. But at least I think what I've taken away is it's going to do some sort of signing and verification of packages, and to do the actual crypto, it's going to essentially defer to other Guile Lisp modules, and one of those modules is PKI, and there's some other crypto module. I'm going to guess that the PKI doesn't do any actual crypto itself. Maybe it just manages keys, but I should have opened those as well, so I think we'll take a peek at it. Okay, so what do we have here? We have challenge. I'm wondering if this is an authentication challenge. So we've got the Guix scripts challenge, which matches this again, Guix scripts challenge. So I'm going to take this as evidence that I'm interpreting this correctly. But now we've got the UI module as a dependency. And we've got colors and scripts and stores. We've got gcrypt hash. I don't know what Surfy is or ICE9. So challenge substitute servers, checking whether they provide the same binaries as those built locally. Here we completely bypass the daemon to access substitutes. This is because we want to be able to report fine-grained information about discrepancies. We need to show the URL of the offending nar, its hash, and so on. I'm not sure what a nar is, but maybe it's some sort of reference to a package. Did this just freeze? I feel like IceCat just froze. Or am I just on the bottom? I don't know. Can I close this tab? Come on, IceCat. Do I have top? It's a lot of red. How am I supposed to read this? All right. I don't seem to be out of CPU. I don't know. Where's that IceCat window? Can I just close this tab? That seems to work. All right. Is this window just borked? Oh me, oh my. What if I do this? Can I click on a thing and pull it out? Maybe? What's going on, IceCat? Well, if IceCat is not going to participate, then maybe I can fall back on Emacs. Emacs seems to be responsive. All right, where were we? We were in Geeks. What is this? Yeah, whatever. Okay. So we were in Geeks, and I had opened a bunch of stuff. So it's still not... Let's close a bunch of stuff. In fact, let's just kill IceCat. Okay. All right. So I don't have like tabs here, but at least I can plot around. All right. Let's see. Can I get all the directories listed in one place? Import, platforms, store, scripts, tests. We were in scripts, I think. What is this thing? Can I disable help windows? I just want to turn off help. Means select help window review. I don't know. I don't want this to like throw a barrier up to me every time I open a directory. Okay. So where were we? All right. So we're in scripts. We were looking at authenticate, And we were looking at challenge. Okay, to ignore local variables list and permanently mark these values as ignored. To ignore the local variable list. The local variable list. All right, let's try searching for this. And for some reason, the internet's taking forever. Oh, man. Can I recursively? All right, I'll just keep pressing I guess. Okay, so here's challenge. So the commentary, challenge substitute servers, checking whether they provide the same binaries. All right. Locally built. Return true if the item was built locally. So how does it figure this out? It's got this is a definition. There should be, but how do we know? So it says bool log file store item. I don't know. So we can query the locally built hash, compare contents, and that's kind of that's a big function. I'm not sure what ports are. We've got archive contents, store item contents, call with nar, call proc with an input port from which it can read the nar pointed to by nar info. All right, let's find out what nar is. Nar info and nar. It would be nice to have the definition, the comment definition at the top. I guess before the inputs. Is that nice? I'm not sure. For me, it would be nice because I don't have to scroll down and search for the comment. Okay, so we're going to read and write Nix archives, aka nar. Okay, so we are working with Nix archives, and that's what nar is. So the Guix really does seem to be built on Nix in the sense that the source code is using Nix. I don't know what this L is here for. We can restore a file set into the store. So what is it doing on what is it doing on top of Nix? I guess it gives you a way of it gives you the scheme, the Guile scheme language as a way of configuring Nix, which I think some people like. And it probably makes different trade-offs than Nix in terms of how it interacts with the archive, I guess. So here's define port. Keep that one around for error conditions. All right. We've got magic numbers. Restore file set. Restore the file set, nar bundle, read from port to the store. The format of the data on the port must be created by export paths. I use a series of nar formatted archives with interspersed metadata. Okay. So what are the local variables? Eval, put with temporary store file, scheme indent function, end. Do we really want local variables? Okay, so that's nar. That's telling us that we're building on top of Nix, and we're manipulating the Nix archives. But we also have some other stuff, like we've got RPM. And so this module provides the building blocks required to construct RPM archives. It's intended to be importable on the build side, so it shouldn't depend on Guix diagnostics or any other host side only modules. And but I don't know what we're doing with the RPMs. So we're going to define GNU system triple machine type. Triplet is going to return a machine component of triplet, a GNU system triplet. I wonder if this is something that is used in a lot of other GNU tools. So we've got the RPM arch type, the lead section. Refer to the docs manual format .md of the RPM source for the details regarding the binary format of the RPM archive. And we've got some signatures. Okay, so this is pretty down in the weeds of the RPM thingy. Oh, do I have God mode? Okay. All right. So quirks. So records had a lot of tests. Let's see what's going on with records. Utilities for dealing with scheme records. Okay, so these are just Lisp records, which I am going to assume are just a way of having like an S expression or a G expression that is used for data, like a record of, I don't know, what do you call it? Fields. Yes, the fields. Okay. So this is just utilities for dealing with fields. Make syntactic constructor. Make the syntactic constructor name for type that calls ctor and expects all of expected fields to be initialized. Defaults is the list of field/default value triples. Thunked is the list of identifiers of thunked fields. And delayed is the list of identifiers of delayed fields. And sanitizer is the list of field sanitizer tuples. So this is pretty interesting because, like, I may be a little bit surprised at this level of this seems pretty low level as far as something like Lisp is concerned. That there wouldn't already be like a way of doing this that they have to do this sort of stuff in the package manager rather than a lower level library. We've got record types. Define a given record type such that an additional syntactic constructor is defined, which allows instances to be constructed with named field initializers. All right, let's take a look at this actually. A la Surfy35. All right, maybe we can look up Surfy. Squash rackets, string libraries, scheme requests. Surfy is currently in final status. Here's an explanation of each status that a Surfy can hold. This Surfy proposes a coherent and comprehensive set of string processing procedures. Okay. String libraries for scheme. Okay, so define record type star. I don't know what star is. Thing, make thing, this thing. We've got a name, a port, and a loc, which is a thing location. Current source location is maybe a location in the source file. This example defines a macro thing that can be used to instantiate records of this type. It's going to have a thing, a name, like foo, and a port, which is the current error port. The value of name or port could as well be omitted. I'm wondering if port is just either part of a inter-process communication or something like coroutines, some sort of message passing where the port just identifies kind of like a mailbox. Where a message can be passed. The port field is thunked, meaning that calls like thing port X will actually compute the thing's value in the current dynamic extent, which is useful when referring to fluids in a field's value. Not sure what a fluid is in this context. Furthermore, that thunk can access the record it belongs to via the this thing identifier. Thing port X will actually compute the field's value in the current dynamic extent. In the current to when you call it, or current to some evaluation time later. Okay. The field can also be marked as delayed instead of thunked, in which case its value is effectively wrapped in a delay ... form. A field can also have I guess that's maybe a little bit like laziness. A field can also have an associated sanitizer, which is a procedure that takes a user-supplied field value and returns a sanitized value for the field. That seems nice to have. So we're going to have a record type star thing, make thing, this thing, and we're going to say sanitized lambda value, and we're going to check if it's a string. If so, we're going to return the value. If it's a symbol, don't know what the arrow is, but I'm guessing this is some sort of string conversion. And if we can't convert, we're going to throw some sort of error. It's possible to copy an object X created with thing like this. Thing, inherit X, name bar. All right. All right. Then we've got some A-list stuff and more field stuff. Cool. All right, what else do we got? Let's look at monads. So we've got, we're going to use the module system syntax, ICE 9. Let's see if we can find out what's up with ICE 9. Why ICE 9? I don't know. Person of interest, fandom, ICE 9, here we go, Wikipedia. Cat's Cradle. Oh, that's the origin. Why do many of the module names in Guile start with ICE 9? I find this unintuitive. Okay, it's some. I guess it's a common namespace name. Export monads, define monad syntax. So we've got this is kind of like is that bind? Mlet, I guess monadic let star, M begin, M when, I guess monadic begin when, blah, blah, blah. We're going to lift some stuff. We're going to list them and fold them and map them in sequence and NEM. And then we've got concrete monads like the identity monad, the state monad. State return, state bind, current state, set current state, state push, state pop, and run with state. This module implements the general mechanism of monads and provides, in particular, an instance of the state monad. The API was inspired by that of Racket's Better Monads module. The implementation and use case were influenced by Oleg Kiselov's monadic programming and scheme. I mean, let's look this up. Monadic programming and scheme. Do we not have an HTTPS link? Wait, I can't call Firefox, right? IceCat? Okay. That juxtaposes Haskell code for a particular state monad. Yeah, so this is inspired by or stolen from Haskell, which is kind of what I figured. Okay. Cool. So this is Haskell-y stuff implemented in the world of Scheme. And to do that, they're using some designs for how to do that properly that are written up in papers and stuff. So IPFS, I guess let's just take a quick look. But I'm going to guess this is IPFS stuff. So this module implements bindings for the HTTP interface of the IPFS gateway, documented here. It allows you to add and retrieve files over IPFS and a few other things. Cool. Lint. Wow, there's a lot of copyrights going back to 2014. So Lint is going to import basically everything that exists. Store, build system diagnostics, download FTP client. Yeah, there's a lot of imports. And we're going to export basically everything we can. Check name, check source, check GitHub URL, check license, define record type, lint warning. So this is a way to encapsulate warning in a specific format. We can make warnings. Procedures for analyzing scheme code and package definitions. Try to find the body of the procedure defining inline by expression. If it was found, call found with its body. If it wasn't, call the thunk not found. Report bogus phase deltas. Okay, so there's a lot here. And I wonder if I can... Okay, so not too huge. Do I have line number mode? Disabled. There we go. Okay, so about 2,000 lines. That's pretty significant. Memoization, I'm going to assume is kind of a generic way of doing memoization, like wrap a function in some sort of memoize contraption. Okay, data type representation of a memoization cache when profiling is on. So we're going to make cache table lookup hits. Cache? Maybe I can pull up some scheme. Scheme syntax. Cheat sheet. I'm curious what things like the asterisk and what else was there? There's something else somewhat mysterious. Okay. So let's highlight all matches of the asterisk. Create a function. It might just be a convention for something. What about question mark? Oh, is question mark like, if not null? Is question mark just a convention for something, for like a what's it called? A thing that checks whether something is true or not. Predicate? Naming conventions. Yeah, and why are the names of predicates in the form of questions? Okay. But what about asterisk? An item followed by an asterisk represents 0 or more occurrences of the item, and an item followed by a raised plus sign represents 1 or more occurrences. But that's oh, this is the regular syntax of scheme, which would make sense because I think that I clicked on the formal syntax of scheme document. Okay, I don't know what asterisk or wildcard. I don't know. But question marks are predicates, so that's nice. Okay. So I'm not sure why this is a predicate. And we've got a table, a cache table, lookups, and we can set cache lookups and hits. Define a syntax rule. Define a lookup procedure proc. When profiling is turned off, proc is set to get. When profiling is turned on, proc is a wrapper around get that keeps track of lookups and cache hits. Okay, so we can do some like computation when profiling is on, and then we turn that kind of bookkeeping off when profiling is off. Quirks. What is quirks? Time traveling is a challenge. Sometimes going back to the past requires adjusting the old source code so it can be evaluated with our modern day Guile and against our modern Guix APIs. This file describes quirks found in old Guix revisions, along with ways to address them or patch them. Okay, so this is like workarounds for old versions of, old versions of Guix or old versions of Guile? Old Guix revisions. Okay. So as things change, versions will change, and I guess Quirks is going to figure out how to handle things. Graph. I want graph, right? Is this where the money is? This module provides an abstract way to represent graphs and to manipulate them. It comes with several such representations for packages, derivations, and store items. It also provides a generic interface for exporting graphs in an external format, including a GraphViz implementation thereof. Actually, maybe it might be that the hard work for the DAG is done with the Nix code, which would make more sense, I think. So maybe this is not like a super central file. I don't know. But we've got a record type and it's got a node type. So I guess graph nodes have like a label indicating what type they are. Well, we've got identifier, label, edges, which is going to be a list of nodes. Convert. I don't know what node type convert is, but we can, by default, we're going to lift one list store monad. So we're going to do somehow lift it, I guess, into the store monad. And I'm going to, wait, so store, store is probably the Guix store or like the Nix, the Guix like version of the Nix store. And so I guess convert is going to like monadify or storify some the graph nodes. We've got names and descriptions. So node edges, cons edge. So I guess we're just going to cons edges together and make some sort of like linked list of the nodes. So maybe edges will be essentially a pointer to the first node, and then that node will point to what the next node is. That's how the C++ translation would be. Node edges type nodes return as a monadic value a one argument procedure that, given a node of type, returns its edges. Nodes is taken to be the sinks of the global graph. So what is a sink in this context? I guess a sink would probably be a node with only with positive or bigger than or equal to 0 in degree and 0 out degree. I guess. Let's see. Is this a general thing? Direct to graph. Sink. Okay. A vertex with, okay, so what is degree plus? All right. Out degree 0, yeah, is a sink. A vertex with in degree 0 is a source. Okay, great. So node back edges return as a monadic value a one argument procedure that, given a node of type, returns its back edges. Nodes is taken to be the sinks of the global graph. I don't know what a back edge is. So back edges. It is an edge UV such that V is an ancestor node of U, but not part of the DFS. What is going on? Not part of the DFS tree. It indicates a cycle in the directive graph. Edge from 6 to 2 is a back edge. What? Is it just... I think it's just copying information. Tree edge and back edge. Is it an ancestor? But not part of the DFS traversal. Oh, okay. So it's, I guess, maybe defined relative to a traversal. A back. Okay, yeah. So that other website I think was copying from here. Edge from 5 to 4 is a back edge. So where's our graph? Okay. So consider an undirected graph below. DFS of the below graph is we're going to start at 3. Go 3, 1, 2, 4, 6, 5. Oh, Lord. Really? Come on, man. and I do where are my add-ons? So I don't want the bookmarks toolbar. I want my what was the menu bar? That thing? View, toolbars, sidebar. Yeah, I don't know why I don't have add-ons. Control Shift A. Wait. Are there any updates? You mentioned already, blah, blah, blah. Firefox, you could try restore defaults. Yeah, we're not doing that. What's up? What's up, Ice Cat? Is it the theme? No? Is it privacy and security? What if I tell it to remember history? Yeah. Why does that make the add-ons come back? I don't know. Okay, so that seems like a bug. All right. Let's see. Not Geeks back edge. I think Geeks for Geeks was the site I was at. All right. And I want to get rid of some of this stuff, actually. Like, I don't need this UPS calculator. All right. Cool. Okay, so where's our back edge? So edge from 6 to 2 is a back edge. So where did the graph go? This is the same graph from before? I think the graph changed. Or am I on a different page? So from 6 to 2 is a back edge, I think is what it said. So we've got, okay. In below diagram, if DFS is applied, is obtained connect using green edges. So from 6 to 2 is a back edge. Okay. So yeah, it's an edge to something that's been visited in the DFS, but the edge, the nodes have been visited. The node has been visited in the DFS, but it doesn't show up. I guess that edge somehow isn't traversed in the DFS, I think is what it's trying to tell me. All right, so traverse depth first, do a depth first search, depth first traversal of nodes along node edges, calling proc with each node and the current result, and visiting each reachable node exactly once. Nodes must be a list of nodes, and node edges must be a one argument procedure as returned by node edges or node back edges. So we're going to traverse depth first and pass in proc, which I think is like a function. So is it going to execute this function on each node? Yeah. So this is going to visit all of the edges of the graph. and execute a function on them is, I think, what's going on. So node transitive edges is going to give you a list of nodes directly or indirectly connected to nodes according to node edges procedure. We can also do reachable count, return the number of nodes reachable. We can get shortest path. All right. Classic graph stuff. We can export with GraphViz. Seems like maybe that would be a separate file just to keep down the dependencies of this graph thing. And we can export to JavaScript. I'm not sure what Cypher is, but oh wait, is this? I think Cypher is maybe the query language for. It's like a graph query language. I think I remember it from Neo4j. I keep closing IceCat, and it keeps being a mistake. All right, so Cypher query language maybe. A declarative graph query language. Largely an invention of Andre Taylor while working for Neo4j Inc. Okay, so it's the Neo4j graph query language. Okay. We've got some graph backend stuff and export stuff. Okay. So that's graph. It's doing graphy stuff. Let's see what else we've got. Are we still in scripts? No, we're not in scripts. Elf. Let's find out what Elf does. So yes, this Elf symbol stuff, and this is like a huge table of stuff. So I'm guessing this is pretty far down in low-level land. Yeah. Okay. We've got lots of byte vectors. HTTP client. NAR info. Packet. Let's look at PKI. So you've got this gcrypt stuff. Gcrypt must be a crypto library for GNU. Not for GNU, for Guile. Guile gcrypt wrappers. What is crypto class? Yeah, okay. Some sort of Guile crypto library. Public key infrastructure for the authentication and authorization of archive imports. This is essentially a subset of SPKI for our own purposes. All right. So the public keys to ACL keys. I guess maybe this arrow is just doesn't have any special syntactical meaning, but maybe it means that that it's like a conversion function. It's like a convention that says we're going to convert a thing to another thing. So we're going to return an ACL that lists all of keys with a Guix import tag, meaning all the keys that are authorized for archive imports. Each element in keys must be a canonical S expression with type public key. All right, we've got more ACLs. All right. Hang on, let me check something. All right. So valid signature. We're doing some signature checking. Here's a signature case. Match the cases of verification of signature against hash and ACL. Okay. But what actually is an ACL? Like, how do they implement it? Return an ACL. It's going to be the result of map canonical S expression to S expression of keys. I guess an ACL is an S expression. Ensure ACL. Make sure the ACL file exists and create an initialized one if needed. So I guess the ACL is a file. If file exists, ACL file. Unless file exists, ACL file. Public key file. And then we can write ACL. So I guess ACLs are files. So I'm kind of curious whether ports is a Guile thing or a Nix thing or something else. Ports, Guile reference manual. Ports are the way Guile performs input and output. Guile can read in characters or bytes from an import port or write them to an output port. Some ports support both interfaces. There are a number of different port types implemented in Guile. File ports provide input and output over files, as you might imagine. For example, we might display a string to a file like this. And this code. Okay. So there's opening and closing of ports and whatnot. So it's like input, output. All right, REPL is going to be a REPL, I assume. Self-quoting. REPL prompt. Handle exceptions. Machine REPL. Run a machine usable REPL over ports, input, and output. And we're going to define a loop. And it's going to call it this classic infinite loop in functional programming. It's going to, just with recursion. Okay. Sets. What do sets do? A simple, or maybe simplistic, implementation of an unordered persistent set based on V-hashes that seems to be good enough so far. Okay, I don't know what a V-hash is. Yeah, another option would be use bounded balanced trees in Adams 1992. Okay, which has faster union but needs an order on the objects of the set. Okay, that's kind of cool. So store, why is there an SSH in store? This module provides an entry point for open connection in Guix store. Passing an SSH :// URI to open connection triggers the use of the code in this module. All right, schema roots. What is roots? Are they like the root nodes? This module provides tools to list and access garbage collector roots or GC roots. All right. So I'm guessing garbage collector roots is the garbage is going to collect on a tree, and it's going to be the roots of the root nodes of that tree or something. Code for working for the store database directly, and it's going to be SQL. Is this SQLite? What else have we got? MariaDB, MySQL, Postgres. Yeah, is this all SQLite? SQLite 3. Okay. Okay, so they're using SQLite as storage, which is always a good choice if you're working locally and need storage. All right, what else is really here? G expressions we should look at. And I'm going to guess it's an S expression derivative in the land of Guile. This module implements G expressions or GEXPs. GEXPs are like S expressions, also known as SEXPs, with two differences. First, references or unquotations to derivations or packages in a GEXP are replaced by the corresponding output file name. In addition, the unexp native unquote-like form allows code to explicitly refer to the native code of a given package in case of cross-compilation. GEXPs embed information about the derivations they refer to. GEXPs make it easy to write to files scheme code that refers to store items or to write scheme code to build derivation. I didn't quite follow that. So references or unquotations. So I guess we're going to pass in something quoted, and maybe it's going to unquote it for us. And when unquoting it, like points to a derivation or refers to a derivation or package, those references are going to be replaced by the corresponding output file name. So if I say like package Emacs, I guess what it's going to do is like dereference Emacs to like /GNU /store some hash Emacs or whatever. Is that what it's saying? In addition, the unexp native unquote-like form allows code to explicitly refer to the native code of a given package in case of cross-compilation. I didn't follow exactly what it's doing for cross-compilation, but something to make it easier to handle. And we're also going to embed information about the derivations they refer to. Okay. So it's like an extension, I guess, of S expressions. So, I guess I feel like I have a pretty good sense of what this folder is up to. Let's take a quick look at combinators. I'm wondering if this is also kind of influenced by Haskell. This module provides useful combinators that complement SRF1, SRFI1, and friends. Yeah, so we have like things like folds. Proc. Define syntax proc. Define proc as a macro such that if every actual argument in a call matches pred, then body is evaluated at macro expansion time. Okay. So this is kind of like a... So what do we got? Define syntax rule, define compile time procedure. So we're going to have some procedure, proc, and one of its... I don't know what arg is, but one of its arguments is a pred. And if that predicate is matched, we're going to evaluate the function at macro expansion time, which I think is probably compile time. That's usually when macros are expanded at the beginning of compilation. And the body must return a single value in a type that has read syntax or read syntax, e.g. numbers, strings, or lists. Okay, so it's going to... It basically has to return something that can be stringified, I guess, because it has to be substituted back in the source code, maybe? This macro is meant to be used primarily for small procedures that validate or process its arguments in a way that may be equally well performed at macro expansion time. Okay, so maybe it's a way of allowing you to write code to do computations and having those computations happen at compile time instead of runtime. So let's look at CVE. I'm wondering if this is about critical vulnerabilities. Common vulnerabilities and exposure feeds provided by, okay. So this is, I guess, it's going to fetch CVE data from NIST. Now let's look at derivations too, just to see what it does. It is exporting a lot of stuff. This is exports, right? So it doesn't have a use module declaration on those things. Yeah, export. Okay. So this is a pretty big interface. Error conditions, Nix derivation as implemented by Nix's derivations.cc. And derivation input, blah, blah, blah. It looks like this is mainly doing like conversion and unconversion stuff, maybe based on what Nix is doing. Like none of these functions are very large. Derivation input fold, perform a breadth first. This is a pretty big function. Perform a breadth first traversal of inputs, calling proc on each input with the current result starting from seed, skip recursion on inputs that match cut. So didn't we already have a function that does general... we had DFS calling proc, and that was not... inputs may not be a graph of the type graph that the other files was working on, but I do wonder, because it's Lisp, if there's a way of having this function and the other kind of graph functions be more in the same place, so that if I know that a function is going to visit every node and call a procedure on each node, it would be maybe easier to reason about if they were all in one place. Although you could make the argument that it's better to have all the derivation stuff in one place. So I don't know. All right, substitution oracle. Return a one argument procedure that when passed to a store file name returns a substitutable if it's substitutable and a #f otherwise. So given a store file, and I think maybe a store file is basically a package. Maybe it's a package and some other stuff. The return procedure knows about all substitutes for all the derivation inputs or derivations listed in inputs or derv, except those that are already valid. That is, it won't bother checking whether an item is substitutable if it's already on disk. It also knows about their prerequisites unless they are themselves substitutable. It's creating a single oracle, thus making a single substitutable path info call, and reusing it is much more efficient than calling has substitutes or similar repeatedly because it avoids the costs associated with launching the substitutor many times. All right. Let's see. Dependencies of substitutables. Return the subset of inputs whose output file names is among the references of substitutables. Okay, cool. So this stuff looks cool. There's a graft with a T. Write a concise preposition of graft to port. But what is a graft? Return, maybe this is part of Guile. Oops. I don't know. Okay, I don't know what a graft is. I'm going to go pretty soon. Let's take a quick look at the GNU directory. We've got bootloader, artwork, build, home, installer, machine, packages, services. Yeah, okay. Linux container, keyboard install image locale, PAM, which is the Linux security module. Configuration of pluggable authentication modules. How many lines is it? Oh, wait. Is there... there you go. 400 lines. All right. No, don't do that. Oops. Okay. What is shadow? Oh, this is like... this is probably password shadowing, right? For configuring the shadow tool suite, login, shadow... login, password, etc. All right, images are these herd. What? Herd bare bones OS. We've got an operating system. We're going to inherit herd default operating system. We've got a bootloader configuration, file systems, Guix GNU hostname. Okay, huh. Herd initialized root partition, herd disk image without OS. I wonder what this file is actually doing though. Name herd raw. Does it import something from herd? It's going to use module GNU system herd. So is that here? Herd. Is that what I just looked at? This module provides system specifics for the GNU herd operating system and virtual machine. So the GNU herd default operating system kernel has GNU Mach and i686 Linux. Huh. Cool. All right. There's one more thing I wanted to check out. Services. I think Guix uses a different, it doesn't use the, so we have herd with a U and herd with an E. And herd with an E, I think, is the GNU Shepherd. Where's Shepherd? We also have Shepherd. And Sync thing. That's interesting to see here. So Shepherd is, I think, the what they use instead of, what's it called? The Linux... The Linux system services, is it System D? Yeah. Yeah. So it's the replacement for System D. Let me verify that. GNU Shepherd is a service manager that looks after the herd of system services. It provides dependency-based management for system services such as SSHD or Xorg. It's written in Guile scheme. It's notably used as PID1 by GNU Guix. All right. So this is like system services, like daemons and stuff, and managing them. Return a Gex starting the Shepherd service, Shepherd packages, etc. Default modules. We can start, stop, one-shot, respawn, auto start. I'm not sure what the trade-offs here are. I assume that Shepherd is less developed and less battle-tested than Systemd. But there are people who have some strong opinions about Systemd. I don't know enough about it to know why they have those opinions, but I guess the GNU people have decided it's worth developing an alternative. Actually, what I wanted to see first was, I don't think this is the implementation of Shepherd, right? So they should import Shepherd somewhere. GNU services herd. Okay, and then let's look at the HERD herd file. It's going to define GNU services herd, and we're going to export some Shepherd stuff. Service not found, etc. This module provides an interface to the GNU Shepherd similar to the herd command. Essentially, it implements a subset of the Shepherd COM module, but focusing only on the parts relevant to the Guix system reconfigure. Okay. So we're going to communicate over sockets. We can open connections. All right, cool. So for not really being able to read Lisp, or not really being that familiar with some of what they're doing, or even what the design goals are, I think I got a pretty good sense of how the code is laid out and what they're up to. They do have a bunch of reading material that I showed at the beginning, like a long manual and some cookbooks and stuff. Ordinarily, if I were just doing this on my own and I was curious about it, that's where I would start. But since I've been looking at these source codes, I started by digging in. So if anybody from the Guix project or who has used Guix a lot, if anyone watches this and I said something like fundamentally incorrect, or if I missed an important part of what's going on, please let me know. But overall, it looks pretty cool. I guess we'll see. I'll keep using it, and I think that for this sort of tool, you only really get a feel for what works and what doesn't by playing around with it and having it break on you while you're trying to do something important, and having to fix that and kind of that's the sort of feedback cycle with any software project. So I'm curious to tool around with it. I didn't realize just how much it was built on top of Nix. So I'll also in the future at some point play around more with Nix. I've used Nix before, just a little bit, downloading a package that was most easily built in a Nix environment, and copying and pasting some of the commands and whatnot. But Nix seems to have a lot of very strong fans, so it's probably worth checking out what they're up to, because they seem to be doing something right. And it seems like Guix is also the people who use Guix, when I see them pop up here or there on the internet, seem to really like it. So I'll be curious to try it out some more. And with that, I'm going to head out. Thanks.